Hello folks, welcome to Wednesday's lesson, and as I always say on a Wednesday we'll have a wee bit more to do because this would be your double period. Today we're going to continue with vectors and we're going to look at the magnitude of a vector. And that's really not as exciting as it sounds because magnitude is just a posh word for size. Okay, so we're simply going to be looking at the length of the line. Let's get started. Okay folks, we've got a vector here, it's 4 along and 3 up, so it's the vector 4, 3 as we've known since our first lessons on vectors. And if we want to find the magnitude, we really want to find the length of the line. If we got a ruler and measured it, how long would it be? It's about 5 centimetres. Okay, so can we work that out? Well, if we ignore the A and think of it just as a right-angled triangle, we've done this many times since the end of second year, beginning of third year with Pythagoras. So we're going to use Pythagoras and we're going to tidy it up into one line. So we'll do square root of 4 squared plus 3 squared. And notice these lines either side are a sign we use to say find the magnitude. Obviously, at some stage, somebody got fed up writing the length of this vector is, or the magnitude of this vector is, and came up with the idea of using a line either side to mean find the length of. And of course, this goes into our calculator, square root of 4 squared plus 3 squared equals 5. There we are, the length of that vector is 5. Let's have a look at another vector. Here's a vector down here called B, and you'll notice that B is a different vector because it's pointing in a different direction, but it's got the same length because it is 3 along and 4 down. So it's the vector minus 3 minus 4, 3 back, 4 down. So when we do the magnitude for that, one thing that we do need to be careful with is if we're using a calculator when we've got negative numbers, this has come up before, make sure that we use the brackets. So it's square root brackets negative 3 squared plus brackets negative 4, close the brackets, squared is. And of course, common sense tells us both these lines are the same length because they're both part of the 3, 4, 5 triangle. So we ask you to find the magnitude of a vector by putting 2 lines over either side. That means go and find the length of this vector. And you do that by a big square root sign and the 2 components squared. And we can use our calculator for that at the moment. I'll just stick with that just now. Okay, I think we need to make a note about that. Learn how to calculate the magnitude, brackets, length of a vector. And as always with notes, you can stop when you need to. So there we are, there's the first bit. Really just what we've been over, but I always feel it's better to tell people first stuff and then let them tell people stuff first, then let them write down. But that's maybe because I can't do 2 things at once. Okay. So that's the first part of our note. And I would like to also include in our second part of the note, there, second part, vector 3, negative 4, negative numbers in brackets to get the right answer from the calculator. Okay. And again, this last wee bit of the note for the moment is reflecting what we talked about before. Vectors, to be the same, they have to be the same length and they have to point in the same direction. So different vectors can have the same length, and that means they are lines of the same length but they're pointing in different directions. Okay, I'd like you to do a wee bit of work from the TJ textbook now. It will appear on the screen in a minute or 2. But first of all, let's just go through exactly what they intend you to do. They give you 2 coordinates. And they want you to find, first of all, the vector that joins these coordinates, and secondly, find the length of the vector. So we'll do the first bit together. Write down the coordinates. Remember, we turn them into position vectors. The vector that takes you from u to v is going to be v minus u. So it is 3, 4. And now we need to find the magnitude of that. So notice I use the magnitude signs either side. Say I'm now finding the magnitude, and it's the square root of 3 squared plus 4 squared, which is 5, just like it was 2 minutes ago. Okay, so if you get that copied down, and then when the questions appear on the screen, you'll know what to do, and we'll just practice that for a wee while. Okay folks, I want to speak now about an issue that's going to come up, because the examples in that first bit were hopefully picked fairly carefully, so your answer was a whole number, but that's often not the case. So what happens? The answer this is us adding to our note. The answer may not be a whole number. Leave it as a surd to give an exact value. And here's an example of the vector 3 minus 2. When we calculate that, 3 squared is 9 plus 2 squared minus 2 squared is 4. So we get, and we just leave the answer as a surd, square root of 13, rather than rounding and getting a not quite accurate answer. So it's possible that the answers will appear as surds. Now, sometimes the surd can be simplified. And here's an example. Oops, let's nudge it up so you can see it. It's the vector 4, 2. That's 16 plus 4, so it's the square root of 20. Now, the square root of 20 is the square root of 4 times the square root of 5. And of course, the square root of 4 is 2. So this is back to our work on simplifying surds. But rather than getting too heavily into that at the moment, I just want to remind you, and it's maybe not something you really thought about, that your calculator actually does the surd simplifying for you, right? So yes, eventually you may be asked in a no calculator paper to simplify a surd, but that's in the future. Let's just stay focused in vectors and let the calculator do the heavy lifting of simplifying the surd for you here. Okay, a couple more questions from the TJ textbook. As usual, they'll appear on the screen for about 10 seconds. You need to pause them, then the answers will appear. And that's practicing finding the magnitude when it's not a whole number. So either it's leave it as a surd or simplify the surd, but to be honest at this stage, let your calculator sort that out. Okay, here are the answers to question 4. These are the exact values without any rounding that would have come out your calculator. So pause here so that you can check you got these all right. And here's the answers to question 5. You can work out the length of each of the 3 sides of the triangle, and it comes out that 2 are the same and 1 is longer, so it's an isosceles triangle. And that's much more typical of the kind of questions we do in higher. There's a big emphasis on trying to deduce what shapes are and where lines cross and things without actually drawing them by doing calculations. Now I would like to look at something that's a fairly typical exam question. So we're back to the notes jotter, just continuing this note. Sometimes it is necessary to do a bit of calculation before finding the magnitude, and I'll show you what I mean. So the vector C is this, the vector D is that, and the question is find the magnitude of 2C plus 3D. So what we have to do is work out what 2C plus 3D is first. So we've doubled it, multiplied that one by 3, tripled it, added them together. So we now know that 2C plus 3D is 210. So we need to do the magnitude of that. So it's the magnitude of 2 squared plus 10 squared, which is 104, which my calculator tells me is 2 root 26. And if 4 goes into that, and 26 can't be dealt with any further. But as I say, at the moment, let's just let the calculator deal with that. And some other day we'll get to have a look at that again, because we'll need to do some revision at some point in the future. So, some questions you have to add vectors together and then find the magnitude or take them away or whatever. So we're going to practice this. The two lines, remember, mean find the magnitude of a plus b. So add the vectors a and b together first and find the magnitude of your answer. Down to here it's a plus 5b, add it together, then get the magnitude. Okay? Pause the video here so you can get that exercise done. Now, so that you can check your work, I've written out the answers for you. First of all, we add the vectors together to get the answer, and then it's the magnitude of the answer. And there's a mixture of ones that come out to be surds, ones that need simplified, ones that don't. And this one, notice, is a whole number, because that vector is 0 along and 7 up. So it's a straight line going 7 boxes up, so that's why its length is 7. But if you just follow the formula, that will still give you the correct answer. Pause here if you need more time to look at that. And here's the rest of the exercise. Pause if you need more time to look at it. Okay folks, what we've got here is another type of question that they like to ask. We've got a diagram. It's best to think of this as some kind of wee game. You've got to get from A to B, but you can only use the vectors P and Q. So vector P is going along one box to the right, and vector Q is going up one box. So to get from A to B, if you find your pathway along here, it would be 3 P's taking you along here, and 2 Q's taking you up here. 3P plus 2Q. Or, if you chose to go up first, it would be 2Q up here, there's Q, so 2Q takes you up to here, and then 3P along that way. And this is because, like numbers with vectors, the order in which you add them doesn't matter. Because essentially the vector is about getting from A, the journey, from A to B. And it doesn't matter whether you go along and up, or up and along. You started at A, you finished at B, therefore in vector terms, that's the same journey. Now, this one's asking us, how do you get from A to D? Well, 2 P's will take us along to here, and 2 Q's, Q takes us to there, and another Q takes us to there. So the answer is 2P plus 2Q. Or, if you want to write it the other way around, 2Q plus 2P. Okay, so the rules of the game here are you can only use vectors P and Q, but you can have multiples of them. So if we want to get from C to D, we just need to go along 1, but up 2. So P, along P, 1P, and up 2Q. Okay? And of course, alternatively, you could have gone up first, and then along. If we want to get from B to C, here's B and we want to get to C. We've got to come back the way. So what we can do is we can reverse the direction of vector P by sticking a negative sign on it. Vector P is going from left to right. So if we go the same distance from right to left, that's the opposite or the negative of vector P. So it's minus 2P. Then we want to come down 2. So that's minus 2Q. Or you could have done that the other way around, minus 2Q minus 2P. Okay? And the last thing that we're going to look at, and I'll maybe fold it so that you can see the question and the diagram, is from A to E. If we want to get from A to E, now E is halfway along. So to get from A to E, we could go along half of P, and then up 2 Q's, and that would get us from A to E. And obviously the alternatively would be to go up first 2Q and then along half P. Okay, so What I would like to do now is just clarify that and pin down the rules in a note. So, new learning intention, learn how to solve vector pathway problems. You've got to find a pathway from, they tell you, from here to here, and you can only use these vectors. So, you need to complete a path from start to finish, and you're told what the start and the finish are. You can only use the given vectors. You can use multiples, which includes a half. And you can reverse the direction of the vector by making it negative. So let's look at this as a game, and these are the rules of the game. Pause here to give yourself some time to copy down. Now we're going to go through some examples. I'm going to use this grid and we're going to make various journeys on it. And I'm going to take a wee while to draw it out because my experience is that this is something people do find confusing. So for each of these 4 questions, I'm going to draw a fresh grid and actually put the vectors on it. So it'd be helpful to have an additional colour. Okay, so first of all, get the question copied into the note so you can see what we're solving. You obviously need to pause here perhaps. So, here's the solution to the first problem. We want to get from A to B. So we go up 3 n's and along 2 m's. And notice if we had gone along first and up, that would also get us there. So that's an alternative answer. In an exam situation, we expect one answer, and in the marking scheme, it will give both alternatives, and whichever one you put down, you get the marks for it. I'm just writing both because it's a note. And later on I write both because in theory half of you could put one answer and half could put the other. So, when you've got that done, let's move on to the next problem. This time we've got to get from C to A. So we can move across using M, but we have to add minus 2n. We've got to reverse the direction of n because it was an up vector, so we make it minus to make it a down vector. In other words, plus minus, just like back in basic arithmetic, plus minus is minus, so the answer we would expect is m minus 2n. But of course there's always an opposite. You could have come down first and then along, which would have been minus 2n plus m. Okay, pause while you get the details of this done. I think it's worth going through this slowly because, as I say, it's something people have found confusing. Third one was to get from B to C. So we've got to come down, but n was an up vector, so we reverse it by making it negative n. Then we had to get across to our left, so we reverse the m vector, and we need 3 of them to get from, so it's 1 down and 3 across. That's minus n minus 3m to get from B to C. And again, just for completeness, I'm writing in that the alternative go along first, then down would be possible. I suppose it's probably because I'm used to doing coordinates that I automatically do the along first and then the up or down. And that may or may not be natural to you. It doesn't matter because either answer is equally acceptable. Now let's look at the last one. We want to go from C to D, and D is in the middle here. So that's where we need to use a half. So from C, straightforward, 3 m's across, and then we need to go half of 1 down. And it's minus because the vector n originally was up. So to make it down, we have to make it minus. So here's our answer, and here's the alternative. Take your time to get this copied in. Now here's exercise 2 for you. I'm going to ask you, just in the same way as we were doing there, to write down how would you get from A to B. And remember, you can only use the vectors A and B, but you can have multiples of them, and that includes a half. And you can make them go the opposite direction by putting a negative sign in front. So could you write down the vectors that would be equivalent to these 6 journeys? And pause here because there's another question coming in a minute. So get this question done first. Here's the next question. A slightly bigger grid and more things to find. Questions 7 to 14. Again, just using the vectors, m is along, n is up. you pause the video here. Just fits in the screen. And our last question, notice the vectors are going different ways now, so you'll need to take that into account, but we're still looking at finding the path in terms of the vectors v and w, so we're looking for answers like 3v plus 2w, and notice these are halfway along, so we'll use some half vectors as well. Okay, pause to get this done. And now here are the answers so that you can check your work. That was for the first page. Pause so you can check that you got it right, and it doesn't matter which of the two alternatives you've put down. Answers to the second page. Pause while you correct your work. I hope you get it all right. And finally, the answers down to number 22, which I'm sure is the longest exercise I've ever made in all these 30 lessons. Okay, pause if you need more time to check your answers. Okay folks, we've covered quite a lot today, so I think that's more than enough, and I'm sure you agree with me. But well done for getting through a double period. A couple of seconds on the exit question, and then off to whatever subject comes next. I appreciate all the hard work you're putting in and look forward to seeing you tomorrow. Bye.